Okay, you should have attempted number 3 and number 4, and we are checking your work right now. So number 3, you're finding the ratio of sine C. So C is my theta, and let's label each of the sides. This is my hypotenuse across from the right angle. This is my opposite, and this is my adjacent. All right, if I'm using sine, I know that sine of theta is going to be opposite over hypotenuse. So I'm going to circle the two sides I need. So I know sine of C is 28 over 35. Four over 5. All right. Now let's go ahead and do number 4, tangent of x. So first I know that x is my theta. So I'm going to label hypotenuse, opposite, adjacent. If I'm using tangent, I know that I need my opposite side and my adjacent side. So tangent of theta is going to equal opposite over adjacent. All right, so tangent of theta is opposite over adjacent. So I'm going to circle my two sides, opposite over adjacent. So I know that tangent of x is equal to 32 over 24. All right, I'm going to put that in the calculator to simplify. 32 over 24. Tangent of x is equal to 4 over 3. All right, I need you to do the rest of these problems on your own. So you're doing 5 through 10, and we're going to check them in class. So go ahead and pause the video and do 5 through 10. And then once you are done with those, you can come back on the next page. All right, we're kicking it up a notch. We are going to now use these trig ratios to find the missing side of a right triangle. All right, so when we have a side and we have an angle of a right triangle, we can use that information along with the trig ratios to find the missing side. The key here is labeling and just understanding what trig ratio we need. All right, so here are our 3 trig ratios, right? Sine, cosine, tangent, SOHCAHTOA, TOA. So what we're going to do is we're going to identify theta. We're going to label the sides of the triangle. After that, we're going to figure out which trig ratio we need, and I'll show you what I mean by that. Then we're going to use the calculator, or if you don't have a calculator at home, we're going to use Desmos to figure out the missing side. So starting off, we're going to label. All right, I'm given the right angle, and I'm given the angle 32 degrees. So if I'm given any information about an angle, that's automatically going to be my theta. So 32 degrees is my theta. From here, I can label everything. I know right here across from the right angle is going to be my hypotenuse. I know opposite of theta is over here, and that makes this side right here my adjacent side. All right, now that I've got my triangle labeled, I'm going to circle everything that has information. And what I mean by that is I'm going to circle the sides that are labeled with either a number or a variable. So see how my hypotenuse has 23? I'm going to circle that together. My opposite side doesn't have anything next to it. My adjacent side has a variable. So I'm solving for the adjacent side. So looking at this, I've got adjacent and I've got hypotenuse. Which one of these 3 trig functions can I use? Can I use sine? No, because I need the opposite side for sine, right? Can I use cosine? That's adjacent and hypotenuse. Yep, that's exactly what I need. So I'm going to say cosine of theta is equal to adjacent over hypotenuse, right? So let's plug everything in that we have. We know that theta is 32 degrees. So cosine of 32 degrees is equal to my adjacent side is x, and my hypotenuse is 23. So now I've just set up a formula to solve for x. Cosine of 32 is equal to the ratio x over 23. Okay, so now that I've got this set up, I need to figure out how to solve for x. So I'm going to give you two little shortcuts to remember. If x is on top of the fraction, kick it. And by kick it, I mean kick the denominator to the front of the trig ratio. So now x is going to be 23 cosine 32. I kicked it to the front. X is 23 cosine 32. Now I'm going to show you how to solve that in this black calculator, and I'm also going to show you how to solve it in Desmos online so that you can do your homework and the rest of this packet at home. All right, so in the calculator, I'm going to make sure my calculator is in degree mode, which it is. See that DEG? If you just clear it, it should default back. Now that it's in degree mode, because I'm talking about 32 degrees, I'm going to just hit 23 cosine 32. That's exactly what you see here, right? So 23 cosine of 32, x is going to equal 19.51. Always round to 2 decimal places if they don't tell you. And why is this a 1? Because the number after 0 is 5, so it bumps the 0 up to a 1. So my missing side is 19.51. Now I'm going to bring up Desmos and show you how to do it on that so that you can do this at home as well. All right, so you're going to go to desmos.com. Once you go to Desmos, you'll hit Start Graphing. All right, from here, you're going to hit this keyboard button right here to say Show Keypad. All right, you're going to type in 23 and then hit Functions, and you'll see cosine. 23 cosine 32. Oh, we are not in degree mode. I know I'm not in degree mode because I didn't get the same answer that I got previously, right? So hit this little wrench right here, and you're going to go down and hit degrees instead of radians because we're working in degrees. After that, it gives me the same number that I got in the calculator, 19.51. All right. Now let's do an example where x is on the bottom. All right, when x is on the bottom of the fraction. So let's go ahead and label everything. I know they're only giving me one angle besides the right angle, so this must be theta. All right, let's label my hypotenuse is the long side. My opposite is the side across from theta, which makes this my adjacent. All right, I'm going to circle all the sides with information. So I'm going to circle the hypotenuse because it's got a variable. And I'm going to circle the opposite side because it's got a number. The adjacent side doesn't have anything next to it, so I'm just going to ignore it. So looking back, I have an opposite and a hypotenuse. Can I use sine? Yes, I can. Sine is opposite and hypotenuse. So I know that sine of theta is equal to opposite over hypotenuse. My theta is 67, so sine of 67 degrees is equal to 14 over x, right? 14 is my opposite side, x is my hypotenuse. All right, so now I have x on the bottom of the fraction, so I can't kick it, right? I'm going to switch it. So instead of kicking it, I'm going to just switch the trig function with x. So if I switch it, I'm going to put x on the left side of the equation, and I'm going to put sine of 67 on the bottom of the fraction in the denominator. And now I can calculate and solve for x. So in my calculator, I'm going to hit the fraction button. I'm going to put 14 on top, and I'm going to put sine of 67 on the bottom. When I hit enter, I get x equals 15.21. I round it up because the 9 bumps the 0 up to a 1. Now, is this degrees? No, it's not, because I'm finding a side length, right? Does it make sense that it's bigger than 14? Yes, it does, because the hypotenuse is the longest side, right? It should be longer than the adjacent side as well. All right, let's do the same thing on Desmos. All right. So now I'm going to do 14 divided by functions sine 67. And this gives me 15.21 as well, because I already switched it to degree mode, right? Okay. Now, I'm briefly going to explain why the kick it and the switch it works with algebra. All right? So, if I'm kicking it, and I've got cosine of 32 degrees equals x over 23. If I'm trying to get x by itself, I need to undo whatever's happening with x, right? Right now it's being divided by 23, so the inverse operation is multiplication. So what I need to do to get x by itself is multiply both sides by 23. That leaves me with x is equal to 23 cosine 32. That's why kicking it works. You're using algebra to isolate the variable. That's all you're doing. So to shortcut that, just think when x is on top, you kick it. Kick it in front of the trig ratio. So algebra is the key here. Now let's see why switch it works. All right, if I'm given sine 67 degrees is equal to 14 over x, if I want to get x by itself, what I can do is multiply both sides by x, right? Because I want to get x out of the denominator. So if I multiply both sides by x, that cancels out x on this side. And I'm left with x multiplied by sine of 67 is equal to 14. Now I need to isolate x on this side. It's being multiplied by sine of 67. And to undo multiplication, you divide. Divide both sides by sine of 67. That cancels out over there. And I'm left with x is equal to 14 over sine of 67. Which is what we did when we switched it, right? So it's going to be the same every time because the algebra rules never change. So just know that if x is on top of the fraction, you're going to kick it. If x is on the bottom, you're going to switch it with the trig ratio. All right, let's do some more problems. Flip it over. All right, find the missing side, round to the nearest tenth. Tenth is 1 decimal place. You're definitely going to need to use Desmos. All right, so I'm going to do number 1 with you. Step 1 is always label. They gave me an angle right here, so that's my theta. Now let's label everything else. I know my hypotenuse. I know my opposite side is across from the theta, and this is my adjacent side right here. Now I'm ready to circle the sides that have either a number or a variable. Adjacent has the number 10. Opposite has the letter x. Hypotenuse has nothing. So I'm going to write SOHCAHTOA at the top as a reminder. So which one of the three uses O and A, opposite and adjacent? That's tangent. So I'm always going to start off by writing the ratio formula. Tangent of theta is equal to opposite over adjacent. And now let's fill everything in. My theta is 27, so tangent of 27 is equal to x over 10. I started to write adjacent. I meant to write 10. All right, to solve for x now, is x on top or on the bottom? It's on the top of the fraction, so I want to kick the 10 in front of the trig ratio. So that gives me x is equal to 10 tan 27. I'm just going to put 10 tangent 27 in the calculator, just like that. And it's going to give me 5 point, and I round to 1 decimal, so that's going to be 5.1. X is equal to 5.1. Let's confirm on Desmos. All right, so on Desmos, I'm just going to put in 10 function tangent 27. That gives me 5.1 as well. All right. Go ahead and try number 2 on your own and then go to the last video. The last video will be very brief.